If you'd have seen the previous video on resultant forces, resolving forces is the opposite to that, where we're going to take a force and we're going to split it into its two component forces. We can do that in any direction, but usually we're going to resolve a force into perpendicular directions. So here we can see three red resultant forces, which could be split into a pair of component forces. And you'll note that in the three diagrams, all the component forces are different. It's usual that we wish to resolve a single force into two forces that are 90 degrees to each other, and often we would look to resolve those in the horizontal and vertical directions. Not always, but it's often the case that it's useful for us to do so. So there we have our diagram of two forces and resultant force. But imagine we wanted to take that single force and split it into horizontal and vertical components. Well, given an angle between the force and the horizontal of theta, then that horizontal component and the vertical component would become r cos theta and r sin theta. Now, the reason why it would be r cos theta is because relative to this angle theta, this is the adjacent side, and you remember from your SOHCAHTOA that cosine is the ratio of the adjacent to the hypotenuse. So the adjacent side is the r cos theta, and the opposite side to the angle is r sin theta. So in this example, we have a 6 Newton force at 40 degrees to the horizontal, and we're going to find the I and J components. So the I component would be 6 cos 40, 4.60 newtons, and the J component, the opposite side, would be 6 sin 40, 3.86 newtons. Here we have two forces. We're going to resolve the 8 Newton force first and then find the resultant of the two forces. So for the 8 Newton force in the I and J direction, as you can see from the diagram, in the I direction it's 8 cos 60, which is 4 newtons, and in the J direction it's 8 sin 60, which is 6.93 newtons. And therefore those three forces are equivalent because in the I direction we've got positive 4 newtons and negative 6 newtons. That's equivalent to 2 newtons to the left, 6.93 newtons upwards, and therefore we would write that as negative 2I plus 6.93 J newtons.